So in this question, we're going to talk about having a heating element in a liquid bath. So this heating element in a liquid bath has a current of 5 amps and a voltage drop of 3 volts across it. And that's basically what I've just drawn here. There's this liquid bath, there's this heating element, and it's just heating the thing up through convection, etc. I'll just draw on some arrows there. It's doing heat. There's a current, this 3 amps and a voltage drop across it current of 5 amps and a voltage drop across it of 3 volts. And then we start it off. It starts heating up the water, etc. We say that the heating element rises to and then remains at some constant temperature. They want to describe the transfers of energy at this point. So at this point of constant temperature, what's going on? And really that's just asking kind of for us to realise that we've got another case of this first law of thermodynamics, which is that we're doing work to this filament, which is therefore heating up. And eventually it's got a point where we rise at a constant temperature, but then we have to use this first law of the change in internal energy of the system is just the total energy transferred to it by heating and doing work on it. We're doing a certain amount of work on it because, again, remember we're doing work through this voltage. This voltage times our current, that's our power, and we'll talk about that in a moment. And so we're doing work on it, and therefore it must be transferring heat if its change in internal energy is constant. Rather, what we have in this case is that its temperature is constant, and therefore it must be losing heat because otherwise it would heat up, right? If it's again, we'll just write that down. We'll have this change in U is just this change in. And again, this is just shorthand. I'm just using that to mean change in internal energy because otherwise I have to write it, and that takes some time. So change in internal energy there. Excuse me. And so what does that mean? Well, that is just equal to the heat that we're transferring. So we'll call that delta Q, where that's heat, plus the work being done on it. We know what the work on it is, right? Because it is just P equals VI. Remembering that from currents, etc., we know that P is P, which is the work done per second. Again, we're just going to think about this as a snapshot. We can think of the change in internal energy per second. It's the heat transferred per second plus the work done per second. If it doesn't hold for every second, it's not going to hold for all time. So per second, that means that whatever the power is, so let's do that now. We'll think about it per second. The heat transferred per second, so, Q over time per second is just going to be the change in internal energy, per second. And so our power is just VI, which is going to be 3 volts times 5 amps, which is 15 watts. That's our power.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.